Hello everyone. Welcome to the second tutorial session of problem solving through programming in C. For those who don't know, this is a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSC, IIT Kharagpur, and I'm one of the two TAs who will be in charge of these tutorial sessions, where we will solve a few questions and generally clear your doubts uh, to help you with the assignments and subsequently the final exam. Okay. Um, so before I start, I will just check if anyone has any specific concerns. And good evening, everyone. And if anyone has any questions regarding me during the session, you can write your questions in the chat box. And I will look at them periodically and I will answer your questions. Otherwise, you can also unmute yourself and ask me whatever question you have during the session. That those are also welcome. All right. That said, let's start the session. So we'll start the session with some theory. So this might have been already covered in the week 2 lectures. So we are looking at different types of software. The first type is the application software, and then the second type is the system software. So as you know, your application software, popular examples of this would be like any media player, like say VLC media player or Microsoft Excel, right? Or even this Microsoft PowerPoint, which I'm using right now. So any of this would be called the application software because they serve a certain purpose, they serve a certain application, they are built for that particular application, and hence they are named so. Now, what are the system software? The system software are those which are important for the running of the system and building the bridge for the application software. So among the system software, you have the operating system, which most of you might be familiar with Windows operating system. You have Windows 11, Windows 10. Some of you might have also used Windows 7 and so on. And then for those who are using Mac, you might be familiar with Mac OS, which is also a operating system, and Ubuntu. Some of you might have used Ubuntu or the different kinds of Linux based OS distributions. So these are the different kind of operating systems. So an operating system needs to be present on your computer so that it can interact with the hardware and provide you with the basic functionality that you need. Like for your computer to run, you need the operating system to be present on the on your system, and then on top of that you install all this application software according to your use, right? And these compilers and interpreters that we talked about the other day, which helps you in converting our high level language to the machine level language. So both compiler and interpreter do this job. So it converts the high level language, which is your source code, and this is what we write the code in. So when we are writing a code in C++ or in any language, it is in any of the modern languages, it is in high level language, and it is a source code, and that gets converted using an interpreter or a compiler to the machine level language, which is directly understandable by the machine, right? And this compilers and interpreters are classified under the system software because it takes some information from you and it interacts with the hardware to really compute whatever you want it to, and it gives you back some. It basically serves as a bridge between you and the machine, right? So that is what system software does. Now you have this application software, say PowerPoint. It uses a lot of features behind it. So someone has written this software where you are provided with all this GUI, this nice graphical interface, and you click buttons and you do stuff, which internally runs certain codes, which again connects to the system software, which further connects to the hardware. So that is how this entire hierarchy works. So basically, you are here, you are the user, and you interact with the application software. That is your IDE for Windows. I would say you have your IDE for writing the C++. So say I'm using things like dev C++ or dev C or yeah, dev C++ is used for both C, C++, and you can use code blocks or you can use VS Code and whatever. So all of these are IDEs which are provided for writing codes in C and C++ or in other languages as well. So you are the user. You are using all these softwares which are application softwares, and they are providing with you with the interface. You are writing your code in them, and then that IDE is going to contact the system software, that is the compiler, which is present as part of the package of the software, and that compiler will connect you to the hardware because that is where all the calculations will happen. So this is the entire hierarchy of how the information is being transferred from the user to the hardware and back. Okay. Does anyone have any doubts with this? I think there was some kind of questions or something. Yeah, yeah, you go ahead, Nandini. Yeah, go ahead, Nandini. Ask your doubt. Yes, they fulfill the purpose of translators because they translate the high level language to the machine level language. Yes. Uh, so it's not like which is mostly used, but certain softwares use some translators and other softwares use like some softwares like C, C++ use compilers, and some softwares like Python use interpreters. So based on the software, you have different translators. So basically, when you have like you need line by line compilation or line by line, yeah, line by line compilation, then people usually go for an interpreter. And if you want to compile the entire code at once, then they go for a compiler. So depends on software that you're using. Yeah, yeah, sure. Um, okay, it's actually it depends on the paradigm of the programming that you're doing. Uh, it's not that one is faster than the other or so on. Rather, if the programming language that you're using is something which can be resolved, like the errors of that can be resolved on line to line basis, like in Python. Uh, Usually people go for an interpreter because it immediately lets you know what is the error in the previous line you wrote. Okay. But in the languages which have a more emphasis on the entire definition of the entire code. For example, in C++, you can write certain statements which might not be meaning anything by themselves, but in the whole scheme of things, in the whole like section. For example, I'll give you a simple example. So in C++, you have this braces, this curly brackets that you need to put at the beginning and end of every function, and you need to write your code, your the block of statements inside those curly braces, right? So Python does not have any such thing. Okay. Now, until say you have written a curly brace, okay, and you are writing the code inside it, and until you put the ending curly brace, there is a error in your code, right? So basically, if you had interpreted it line by line, it would have shown you an error as soon as you had put the opening curly brace and not the closing curly brace. It would have shown you an error. Okay, but we don't want that to happen. In Python, we don't have that. We just keep on writing. There are no curly braces. We just give an indent. We start writing. So basically, it is fine with us using an interpreter in Python. But in C++, the coding structure that has been developed for C++ supports the use of a compiler better than an interpreter. So it's not a case of being faster or so on. If you want like the errors to pop up immediately after you write the statements, it's better to use an interpreter. But it's about the coding paradigm that you are following, that the code, the language, the way that it has been developed, that also has a very important role in deciding whether we need a compiler or an interpreter. Yeah. Yes. Uh, like these are the two variety. These are not like exact translators, right? I mean, these are the two types of translators that are available, right? One that does the entire thing at once, and one that does it line by line. So I don't think there are other varieties of translators available, but definitely a translator, a compiler that you use for C or C++ will not work for say Fortran, right? So there are unique translators for each of them. Just that we classify them together as either compilers or interpreters. Yeah. Okay. So yes. Yeah, go ahead. Okay, just a moment. Mhm. Yeah, okay. So basically, single user, during the time when operating systems were initially being developed, we had single user operating systems where only a single, basically, only one user account can be possible for that particular operating system. But now, as you can see, for any operating system, we are able to create multiple accounts, multiple user accounts, and it is even possible for some systems to support multiple users logging in at once, right? And accordingly, like for example, you talk about the servers. You have the server systems, right? So the server systems are designed in such a way that multiple users can log into the server and they can do their work and they can log out. So multiple users can access that particular operating system at any point of time. So that is basically what it means. Yeah. All right. Okay. So if there are no more doubts, we can move ahead. Uh, can I ask you all to please mute? Thank you. Um, all right, let's move ahead. We have okay. Now, in the previous lecture, we saw that variables. What are variables? Variables are memory locations in the RAM, which get allocated when we try to compile the code, right? Now, uh, now this there can be many different variable names, right? So what is the ideal? What are the rules for naming of variables? These are as follows. So these are the rules for naming of variables. So the first is there should be a string of alphanumeric characters. So basically, we are talking about A to Z and 0 to 9 alphanumeric, with some special characters allowed, which is underscore. So underscore is a allowed character for, so it can be like I can have the name as problem underscore 99. This is fine. So this is a completely fine variable name that I can use. Now the second thing is it should not start with a number. So like I said, you can use numbers, you can use characters, you can use underscore, but it should not start with a number, right? Then the third is it should not be a keyword. Now there are certain words in C, in C++, in any language which are reserved for some particular purpose. They have a special meaning for that particular language. Say, uh, if we will see in some time that if, else, int. So you must be familiar by now with int and float, right? So the integer type value and the floating point type value. So all of this, even main. So all of this are reserved words. That means they are keywords. They mean a certain thing to the compiler. They have a special meaning to the compiler. You cannot use them as variable names. Okay. So that is what it means when I say that it shouldn't be a keyword. So this and any other, like next you will learn about for loops and while loops and so on. So you will be encountering all these keywords as we go ahead, and all of that uh, are keywords. They cannot be used in variable names. Okay. Now the next point is the naming of variables is case sensitive. Okay, so that is why I wrote A to Z in capital and A to Z in small separately. So say you have a variable which has the name problem underscore 99. Now I write a variable in this manner, problem underscore 99, but with a capital P. So this will be two distinct variables. The compiler will consider them as two distinct variables. So I cannot write, so I can define them and store different values in this. Okay, so because they are completely distinct variables, that is what it means by case sensitive. So uppercase and lowercase characters does not mean the same to the C compiler. Okay. Then the final one is just a recommendation that is given by the developers. That is not to use, not to start a variable name or an identifier name with an underscore. So instead of this, like preferably they have said not to use a variable name like this, like underscore problem 99. Okay, preferably not. And why not? So that is the first question, and the answer to that is option C here, which is to avoid conflicts since library routines use such names. All right, so there are a lot of different libraries. So there is a standard library. Okay, in C there is a standard library. Okay, so it's I think it's yeah, and there are many predefined functions and so on. So a lot of predefined functions and templates and so on are available in this library. A lot of library routines, as they call it. So all of this library routines, a lot of this library routines actually start off with underscore, because there is like if it starts with the underscore, it's probably a library routine we are talking about. Okay, that is the uh, I would say that is the norm in the computing world. So the developers have written the libraries with the names starting with underscore mostly. So whenever you could still use an underscore to start with an identifier unless and until it does not match with any of the library routines in the standard library. Otherwise there might be conflicts because you are using a word which is already present in the standard library but for a different purpose. So there might be some conflict there. So preferably the developers have asked not to start variable names with an underscore for that purpose. Now, just a small question here. Which of this is an invalid variable name? So let's look at the first one. So it can be alphanumeric. So A to Z, 1 to 3, 0 to 9 can be possible, and combination of that good enough, underscore fine. So this is okay. This is valid. Now the next one is capital P. It starts with a letter, so it should be fine. You are not using any invalid characters here, so this is fine as well. Now this, however, you can see it starts with a number, and the rules say that you shouldn't really start a variable name with a number. So this, I would say, is the invalid variable name. So this is not suggested. Okay, this is not suggested, but it's not invalid either. So if you use this as a variable name, it will still not give you an error. But if you use this 748 underscore PAX as the variable name, it will give you an error. So although the option D is not recommended to use it like that, but it's not invalid as well. Okay. So I hope it's clear to everyone so far. Okay. So now let's talk about structure of a C program. So every C program needs to have a, sorry, do you have yeah, you have any doubts? Yes, I can hear you. Yeah, go ahead. Yeah, yes. Mm-hmm. It's 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 valid. It's valid. So it can be capital or small. What I wanted to say earlier is that it's case sensitive. What I wanted to say is this variable, this is problem 99, problem underscore 99 with a small p, and problem underscore 99 with a capital P. They are different variables. They are different variables, but both of them are valid. Okay. So that is what I meant to say earlier. So yeah, 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 you're welcome. All right. So if there are no more questions, let's move on to the next. So we are talking about the structure of a C program. So a C program needs to have a main function and can have more functions as well. And then it has an inbuilt library of functions. So this is what I was talking about, the standard library. This is the standard library I was talking about, that it has an inbuilt library of functions which you can use for different operations. Now, a C program includes this statements, which is called a preprocessor directive. Okay, so what it does is it tells you what files to include. Okay, so now this standard library of C has a lot of discrete files which serve certain purposes. Okay, now these are called header files. Like with .h, they are called header files. Now what this header files, each header file does, for example, this stdio.h header file, it operates with the standard input and output. Okay, it has functions defined inside it which help with standard input and output operations. So that is the purpose of this particular header file. Now if we want to use like standard input and output operations, like you want to print something or you want to take some value from the user or something like that, you need to include this particular header file by writing this preprocessor directive, which is hash include, and then in angular braces you write the header file name. Okay, so when I write stdio.h, it will include all the functions that are present in stdio.h related that, and those functions are related to the input and output, and it will include all of those functions in this code so that I can use any of those functions, say the print functions and so on. I can use that only if I have included this particular header file in the preprocessor directive. So basically I'm telling the processor that you please include this particular file because I'm going to use some functions from this particular file. So that is what it does. And then there is a main function. So this is the main function, and every C program needs to have a main function. If it is supposed to be running by itself, like if you are able to execute the C program, it needs to have a main function, because the when you try to execute a C program, the execution starts from the main function. So no matter what other functions you have in the code, the execution will only start at the main function whenever you run a C program. Okay, so it needs to have a C function. Sorry, it has a main function, and inside the main function we can write whatever we want. And what else? So these are whatever block of statements you can write, whatever operations you want to do, you can do it inside this block of statements with the main function. And this is what I was talking about. So every function in C, whenever you're trying to write, has to be enclosed, like this block of statements has to be enclosed within a pair of curly braces, as you can see, this and this. So there has to be an opening brace, there has to be closing brace, and within this braces you have to write your block of statements. And here there is this int and return 0. I'll explain that later on when we go to the functions, we reach the functions part of the course. So basically what this does is, the main is supposed to return a value of type integer, and we are returning 0 from the main function. So that is what it does, but I will explain it in more detail when we go into functions, probably around week 6 or so on. All right, now let us try to solve this question. So basically what we have here is, we have a main function, we have a variable x. This variable is called x, and it is of type integer. So it is a this variable x can store only integer values. Okay, and then we are allotting it to some some operations. We are doing some operations with some numbers, and we are trying to store that value in this integer variable x. So what do you think should be the answer here? Okay, so basic. All right, so let's see. So for okay, so lots of different answers here. Um, okay, all right. So let's see what should be the answer here. So there is something called operator precedence. So there are terms that you should be familiar, like you will get familiar with. Uh, Bodmas, but not exactly. So there are two things called operator precedence and operator associativity. So for now, we will use BODMAS, but BODMAS is not the way that it has been defined in this particular programming language. So rather, there is a table which we will follow, because there are, yes, the operator precedence and operator associativity table that we will usually follow, because BODMAS is only for mathematical, for arithmetic operations, right? For multiplication, division, and addition, subtraction, and so on. But in C, you have a lot of operators which do a lot of jobs. Like you have logical operators, and you also have like relational operators. There are lots of operators. So we should know exactly what operator operates first and what operates after that. So there is a detailed table for the operator precedence and the associativity. Okay, and I will touch upon that later on. But for now, as far as arithmetic operators are concerned, uh, for operators like multiplication and division have a higher priority than plus minus operators. So precedence goes like this. Okay, so first is the division and the multiplication operators have higher precedence than the addition and subtraction operators. Okay, now when there are the operators of similar precedence, for example, here you have a multiplication and a division operation, right, next to each other. So which should be done first? So that is where our associativity rules comes into the play. So for this particular operators, that is multiplication and division, the associativity rules say that we will go from left to right for this as well, from left to right. So we'll go from left to right and solve. Okay. So here we have operators of the same precedence, which is multiplication and division. So what we will do is we will start solving from the left to the right. So that will be 4 into 5. It will be evaluated to 20. Then we will divide it by 2. So this will become 10. And then the operators of higher precedence are gone. You are left with an operator which is plus, the addition operator, which has lower precedence. So we'll just do that. And then you do plus 9, which will give you 19. So that is how the value of x becomes 19. Yes. Structure. Okay, so basically what I'm trying to, so do you have a issue with the structure of the C program or this particular problem, like this particular question? Okay, okay. Yeah, that's okay. So basically every C program should have a main function and it can have many more other functions. And so there are three things. Okay, first is the main function. The main function has to be there for every executable C program. And that is where the program execution begins. So program execution, when you execute the program execution begins here at the main function. Okay, so main function has to be there. So when you are writing a C program, the first thing that you have to keep in mind is I have to write a main function. Okay, whatever statements or whatever other functions can be there doesn't that is a secondary thing. Main function has to be there. Then if you want to use any of the functions from the inbuilt library, so there is an inbuilt library of functions for C, which is a standard library. Now if you want to use any functions from the standard library, you want to include that particular header file as a preprocessor directive. So say I want to use print, say printf statement, which is for printing something to your screen. So I want to print some values to my screen based on whatever I have done. I want to print some values, or say I want to get like to take some data from the user. So I want my code to take some data from the user. Okay, so in all those cases, so let's say, yeah, there are many other things about that, just some functions. Okay, now all these input and output functions are defined under stdio.h, which is the standard input output header file. Okay, so the standard input output header file is something that the developers have written. It contains a lot of functions which we can directly use once we have included it in our code. So, and to include them in our code, we need to write it as hash include. Then in Angular braces, we write the name of the header file. So if we write this, then we can use all the functions which has been defined inside stdio.h. Okay. Conio.h actually is, yeah, I forgot the exact, like the, sorry. Yeah, Conio.h is, yeah, control input output. Yeah, maybe I am not familiar, like not familiar, but like to be honest, Conio.h is like for our course. I don't know how far it is going to be required, but it's also a highly used header file in the C language. So yeah, I mean, I can give you some details maybe in the next class, but I don't use it much, to be honest. Yeah. Yeah, yeah. Yeah, I mean that is the syntax. I mean that is the syntax of how you include the header files. Like for including any header file, you have to write hash include, and then in Angular braces you can write the name of the header file. Like that is the syntax that you have to follow. So every programming language has its own syntax. Like why do we write int x, right? Why do we write the return statement and then some value after that? So it's basically a syntax that you have to follow. If you want to use the programming language, then you have to follow the syntax. Yeah, you're welcome. Yes, one at a time, please. Yes, so here there is no real requirement to use the stdio.h. It would have worked just fine without stdio.h because you are not using any functions which are defined within stdio.h. So it's just this program is just a sample program. So here you didn't really need to use a stdio.h. It will not give you a output as such, but the question asks what is the value of x in this C code. It does not ask like what is the output from this C code, right? So there is no output as such. If you just run this C code, there will be no output, but x will be allotted some value based on some computation, right? And that is what the question asks, that what is the value of x in this particular C code. Yeah, it's a sample program. Yeah, yeah. Yes. So there is another preprocessor directive. It's called hash define. It is used to define macros. Like it is used for some different purposes. So you can define macros using hash define. And there are like a host of preprocessor directives. Include is just one of the preprocessor directive, which helps you include the header files. I'll be talking about the other preprocessor directive as well later on in the course. Maybe you will see this define just a few slides after this. We can use it very in a very versatile manner. Yeah, it is a preprocessor directive as well. All of those are preprocessor directives. Undef, if def, like there are a lot of preprocessor directives that you can use. But for now, let us be only concerned with include, which is the most prevalent one because we need to use functions from the standard from the standard library. And include is the most important preprocessor directive, which allows us to do that. Yeah. All right. So does everyone understand how this the value of x came to be 19 here? Okay. All right. Then the other question that I have for you is that in case of ordinary int variables, when I say ordinary int, I mean that it's signed int. Okay, that means it can have a sign. It can be 53 and minus 53. So x, you can set x to 53 or set x to minus 53. So that's what I meant by ordinary. That means it's signed int variables. It has a sign. Okay. So in case of signed int variables, which of these statements is true? The leftmost bit is reserved for the sign. The rightmost bit is reserved for the sign. There is no bit reserved for the sign, or none of the above. So as you know, like int variables, they occupy 4 bytes of space, right? One int, depending on your whether it's a 64-bit or a 32-bit. This is for a 64-bit system. So for a 64-bit system, you will have uh, one int variable occupying 4 bytes of space. That means, and if you remember, 1 byte is 8 bits, right? So 32 bits of space basically. So if you draw that like really long one, so first I will just divide it into 4 parts, and each of these 4 parts will have like 8 divisions. Yeah, there will be some further division. So there will be 8 divisions in each of this, right? And that will make a total of 32 bits. So yeah, so what do you think the sign of the int variable, where does it get stored? Yeah, yeah, you're correct. So the leftmost bit is reserved for the sign. So this particular bit that you are talking about, the leftmost one, will have a uh, will store the sign. Of course, it will be stored in 0 and 1. Okay, and I think 0 means it's a negative value, and 1 means it's a positive value. But I would prefer if you check this across with on the internet. Uh, so the leftmost bit is reserved for the sign in case of signed integer variables. Now there can be also some variables which are called unsigned integer. Okay, you can also define unsigned int. What does that mean? It can be only 0 or more. The values can be 0 or more. That means only positive part of the spectrum can be stored in those variables. You cannot have negative values stored. So basically you have, so in that case there is no bit which is reserved for the sign. So all 32 bits will be used for storing the value that you have. Okay. In this case, in case of signed int variables, you will have only 31 bits to store the value, like the absolute value, and one bit which will store the sign of the integer value. Okay. But in case of unsigned, you will have all 32 bits which will be used for storing the value of the integer. I hope that's clear. Yeah, just one at a time, please. Yeah, so when I say ordinary, I mean that it's a signed int variable. That means it can store positive and negative values both. So it will take one bit for the leftmost bit for storing the sign of the integer variable. Okay, and the rest 31 bits will be used for storing the absolute value of the integer. Is that clearer? Yeah. Yes, yes. If it's a signed integer, then if you have just defined it as, okay, have you checked this on the internet? Okay, yeah. Then yeah, I stand corrected. So for positive, it's 0, and for negative, it's 1. Okay, thank you. So basically, when if I define like something like this, int of x, so this basically is a signed integer. Okay, by default, C considers it as a signed integer. If I want to define a unsigned integer, I have to write particularly that unsigned int x. So in this case, it will not reserve any bit for storing the sign. But as you asked earlier, if I'm defining a signed integer, which is the first case, int x, in that case, even if it's a positive value, still the leftmost bit will be reserved and will have a value of 0 because it's a to show that it's a positive value. Okay, does that answer your question? Yeah. Okay. So yeah. Okay, so return 0 basically, okay, probably this question will be better answered when we cover functions later on in the course. Return is something that basically return is a keyword which does the job of returning some value to where the function has been called from. Okay, so we call the main function from somewhere, and yes. Yeah, so scanf is a input statement. That means you're taking the input from the user. So scanf is used for that purpose. Printf is when you want to give out some output to the computer screen. But scanf is a statement which you use when you want to take some input from the user. So they have like scanf is used for input, printf is used for output, right? And yeah, regarding the return zero question, we'll deliberate it when we look into functions later on in the course. But for now, it's just know that it returns zero, the value of zero. Like if you write return zero, it will return the value of zero to wherever the main function has been called from. Okay, so for now, just I think this information will not be using the return as such, like with some significance. Later on, when we cover functions, you will learn the actual significance of the return statement. Okay, so I would ask you to just hold on till then. Yeah. All right. So let's move on to the next question. So here I have questions for you. Now we are going into specific printing, like print formatting and yeah, data types as well. So by now you must know that we have int, that is integer data types, and similarly we have float, which is floating point data types. Floating point data types means it can store digits after the decimal. So it can store values like 53.3233 and so on, like points after the decimal. But integers can be only say integers. Yeah, 53 minus 53, whatever, like this kind of. Then you have higher data types than this. Like in the floating point data type, you can have larger data, like to store a bigger value. You have further data types such as double and long double and so on. But we'll not be concerned with them right now. You can learn more about them if you want to. Apart from that, we have a character data type, which basically stores characters. Say the character C, the character B, even the character space is a legitimate character, and it will be stored as a character. We can store it in a character variable. So it occupies 1 byte of space. It will occupy 1 byte of space, a character variable, and yeah, and what else? So we can have Boolean as well, but that is not a standard data type in C. So for now, let's be concerned only with this data types, the character, integer, and the floating point data. So these are the different data types that we can define variables of. Okay. So in the first question, what we have is we have a code. What it does is it defines a floating point floating point variable b and saves the value 57 to it. Okay, and then I use a printf statement. Why? How would I, like, how was I able to use it? Because I have included the stdio.h header file, so I can use the printf statement. So I printf and percentage f. So percentage f basically is used to, it's a placeholder, it's a control character. Okay, so what is a control character? It's a placeholder. What it does is you can decide how your output will look like. Okay, so if I'm writing in this double inverted comma, I write percentage f. That means the compiler will know that I am trying to print a floating point data. Similarly, if I write percentage d, it will understand that I am trying to print an integer. Okay, and percentage c, it will understand that I am trying to print a character. Okay, so this is how a printf statement is written. So you have percentage f in this double inverted commas and comma the variable. So the value, whatever value is stored in b, will be printed according to a floating point. How a floating point variable would be printed, according to that, it would be printed here from this. Yeah, I'll get to that. I'll get to that. So before that, I need you to answer this question, that how would this output look like if you do a percentage f and print the variable b. So how will this look like? A single zero, right? So you will have six zeros here. So 57.6 zeros, okay, followed by six zeros, because that is the default floating point, like the default number of decimals that percentage f prints after the decimal point. So you'll have six zeros because you did not specify whether you wanted one digit after the decimal, two digits, or whatever. Okay, so you did not specify any of that. You just said percentage f. That means you want to print it as a floating point. Now, the default, sorry, yes, I mean that is the default. That is the default now print formatting of percentage f. So percentage f will print by default. It will print six zeros after decimal, like six, not six zeros, six digits after decimal. That is its default setting. The print formatting for percentage f is six digits after the decimal point. So here we do not have any digits after the decimal, so it simply printed zeros here. Okay. Now, if we want to format it properly, like you want that, I want to get only 57.0. Why should I get 57.6 zeros? Like it doesn't look good. So what I would say, I would write here instead of percentage f, I would write percentage point one f. Okay. Now what this point is also important. So point one f. That means I am saying to the compiler that I want only one digit after after the decimal to be printed. Okay. So this would, if I, instead of writing percentage f, if I write percentage point one f, I would get 57.0 would be printed. Okay. Uh, and that is what someone was asking, what 2.3 means, right? So this is the minimum number of characters you want, minimum number of characters, and this is the number of digits after decimal. Yeah. Hmm. Yeah. Sorry, I couldn't hear you. Can you repeat that again, please? Uh-huh. Mm-hmm. It will print the next digit, but yes, that is a good question. That is a very good question, and that is in fact what I was going to ask you when I was going to ask you to solve this question. This will answer your question exactly, like what exactly will be printed. Okay. Uh, no, I mean for this, yes, it will print 57 point then six zeros. But what about this question, the question on the right? Are you sure? I feel the answer will be option D. No, but there is a catch here. It rounds it up, like whenever you are trying to like do a print formatting, say here I'm saying that I need three digits after the decimal, and hence I write percentage point three f. What it does is it looks at the digits after that. If it is higher than 5, it will round this up to 3. So if you probably run this, you will see that it will give you an output of 0.653 instead of 2. Yeah, after the decimal, three digits after the decimal. Yes, yes, points after so the number of digits after the point is 5. So in that case, this would print something like this. Just wait a minute. Let him complete his question, please. So yeah, what were you saying? Like how will you know if it is 5? Sorry, what? If if it is greater than 5, only then it will round up. Otherwise not. If it is 5, still it will not round up. Yeah. Sorry, what? Can you? Yes, yes. You have to check the next number and then you have to round it up accordingly. Yeah. Yeah. Go ahead, please. So you have A is equal to 4512.652 and you want percentage point 5F, right? So you will have like this. Answer will be this. So you will have two zeros after that. Yes, there is a limit to it. Basically, at some point your there is a limit to what float can store, like the decimals that float can store. Okay. If you have a very long like lots of numbers, say recurring fraction, right? So in that case it will be an unending series of numbers after the decimal point. So float only can hold so much. Okay, it will print, there is a maximum limit to that. S- then probably I would ask you to go for a double or a long double type, which is a like, think of it as a big brother to the float data type, where you can store more digits like till higher precision. So floating point means it's a single precision, and double means it's a double precision. So it has twice the precision of a float. Okay, so there you can go till more like decimals, like bigger and bigger uh, number of digits after the decimal. So if you want to go that high, yes. Hmm. That will be option C here, which is 652. So unless it is greater than the fourth digit is greater than 5, it will still be the same. Like only if it is, because this is 6, it will round it around the digits from 2 to 3. If it was 5, then you would have 652 being printed. Yeah. Mhm. Okay. Yeah, if you want to write 2.3, the answer will be still the same. Like in the same, if I write A is the same value as this, and then 2.3f, the answer will be still the same. Why? Because as I wrote here, this first character here, like this 2, means the minimum number of characters that you are printing. Okay. Now, this has how many characters? You have 8 characters here. So I have just said that you can print a minimum of two characters. That means you are free to print more than two or more characters. Okay, so it will simply print whatever number of characters is there. But if there is, like, you have say, I'll give you another example. Say I'm saying a is equal to 1. Okay, okay, yeah, like 1.5, say is equal to 1.5, and I'm trying to print say 4f. Okay, right, 4f, or say 4.1f, I mean, let's say 4f. So what it will do is it will see here. So these are only three characters, right? 1, 5, and the dot. So there are only three characters. But I have said to the code, that to the compiler, that I need minimum of four characters. So what it will do, it will, okay, not this one. This is not a good example. Wait, why it is not a good example? I'll say because there are floating. If I don't give anything, um, yeah, if I write it like this, then yeah, it will probably highlight this example better. So I'm saying that I want only one digit after the decimal, okay, and I need minimum of four characters to be printed. So this will print like 1.5, okay, because three characters, but there will be a space in the front. Like there will be one space in the front, and then it will and then it will print 1.5. Are you able to see why? Because that will make a total of four characters now. Is it clearer? Like how this first part of, okay, yes, point is also considered as a character. Okay, let's say I'm saying 4512 point this, right? Now I print percentage, say point 3. How many characters do I have? It is 8 characters, so I say 10.3f. Okay, let's say I'm writing 10.3f. So what will happen is you have how many? 4 plus 4, 8 characters here, and there will be two spaces before this, because I have said that I need a minimum of 10 characters to be printed. So it will leave two spaces, and then it will print the 8 characters. So it has to be minimum 10 characters, and then this point 3, it has rounded up already, and this is what will be printed. Is that, are you able to understand that? Yes, I mean, uh, yes, sure. So basically, when you are trying to print it through a printf statement, so printf statement considers the number of characters that you are giving it. Okay. So here, when I say that I have a variable a equals 1.5, so it has a value of 1.5, and I'm trying to give this print formatting, which is percentage 4.1f. Okay. Point one, you understand already that I am just saying that I need only one digit after the decimal. Now, if there is only one digit after the decimal, so the number will be 1.5, right? It will not be 1.50000 whatever. It will not be like that. It will be only 1.5. So if I say 1.5, how many characters are there in this particular, like, let's say this is, uh, how come there is one character? No, I'm talking about, like, consider it as a string. Okay. Like this is a number. I know that it's a number, but when you pass it to a printf statement, it has to print it as a string. So when it prints it as a string, so one is also a character, right? In that case. So basically, when you have to say, you have to type 1.5 on your keyboard, you have to type 1, you have to type point, you have to type 5. So you have entered three characters. Do you understand what I'm trying to get at? Yes. So there are three characters in this particular number. So this number 1.5 has three characters, a 1, a dot, and a 5. Now, but I am saying that I need at least four characters to be present. I need only one digit after the decimal, and I need at least four characters to be present. So when I say at least four characters, but the program has three. Like it has one, it has point, it has five. So there are only three characters to print. So what will it do? It will give us a space before 1.5. In order to make it at least four characters, it will just give us one space and then it will print one dot and five. So that will make a total of four characters. What do you mean not available? Yeah, I mean it's a character. It's a character in according to the ASCII format. Yeah, it's valid. It's valid. Yeah, it's a valid character. Space is a valid character. What class name? Yes, you can't use space in that while naming files. I mean that is I would say I think that is limited to certain operating systems, but you can use space. Yes, I think you can. Yeah. All right. Is this clear now how like this control characters like the print formatting works? Mm-hmm. Yeah, yeah. Okay, so when you are trying to print a floating point, you have to use percentage %f. When you are trying to print an integer, you will use percentage %d. When you are trying to print a character, like print from, okay, let me change the statement. Okay, if you're trying to print the value of a floating point variable, you will go with a percentage %f. If you're trying to print the value of a integer variable, you will use percentage %d. If you want to print the value of a character variable that is of type char, you will use percentage %c. Okay, so every variable data type that you have, every data type that you use has its own format specifier that you have to use in order to print the value according to how it has been stored. Okay, is that, yeah? No, percentage does not signify print. Percentage is, so this entire thing means something. So this entire percentage %d is a format specifier, as the previous person said. It's a format specifier. That means it's just a placeholder for the value that you are going to give later on. So if I write percentage %d and then I put say some integer x, that means I'm saying I want x to be printed in place of this percentage %d. Okay, that's all it means. So it's a part of the format string. Yeah. For strings, depending on how you store it, you would use percentage s, or if you print it character by character, you would have to use percentage %c. But we will look at strings at the, I think, week 11 or week 12, and I will cover that in more detail then. Yes. Hmm. Yes, you can. You can force it to print in a integer format. Uh, yeah, sorry. Before that, I'm going to answer his question first. So yeah, you can force the program to print it in whatever format you want, but yes, you will definitely lose the digits after the decimal. If you want to force the floating point variable to be printed as an integer, then you will definitely lose the digits after the decimal. But it's possible to print that. Uh, okay, that's a good question. You can try it out. I'm not sure exactly what it will do because it's a uncommon, uh, like it's a forceful typecasting that you are doing. So I'm not very sure as to what it will do. But yeah, I think you can try it out and let us all know. Yeah. Yeah. And what was the other question? Sorry, can you repeat that? Yeah, someone asked a question in between. Can they again ask it? All right. If not, then we can proceed to the next slide. Float is still 32 bits, which is 4 bytes of space for 64-bit systems. Yeah, so is int. Int is also 4 bytes. Yeah, okay. Depends on how you define the string. But like the strings, depending on string is basically a combination of characters. So when you're defining the string, you specify the number of characters. But yeah, I will not be answering this question directly so as to avoid confusion among those who are not familiar with strings. So we will take this up when we reach the strings part of the course, which is week 11 or 12. Character takes up 1 byte of space. Escape sequences are treated as characters, and basically they are okay. Yeah, escape sequence basically have this special function where you use them to get certain the output to be more like the way that you want. Okay, so slash n, yes, it's a new line. This gives you a tab space. This gives you a backward, like you can move backward through slash b, and this gives you a backward slash and so on. Like there are plenty of escape sequences which you can use for formatting your output, like making them look better. So if you write slash n, it will automatically move to the next line in that case, like next line in the screen. Yeah, yeah. Yes. Sorry. So yeah, just a minute. So yeah, what was the other person? Uh, that that is fine. I mean, 0.3f basically means you're saying I want any number of characters because the minimum number of characters is 0, so it will print as it is. Yeah, yeah. So what was the other question? So someone was asking about data types or something. If Sorry, I couldn't hear you. Yeah, the answer will be the same. So basically, writing it as 0.3f or percentage 0.3f is the same thing. It does not make any difference. It's the same thing. Either that is why you can, instead of writing 0, you can skip the 0. It will print the same thing. Okay. Yeah. Yeah. All right. So let's move to the next slide. So let's see what the correct value of this variable x will be. Can you compute that? Option B or D? B for Bombay? Okay. D for Delhi. Okay. Yeah, yeah. Okay. I got you. All right. So what exactly are we trying to do? We have, these are floating point values, the floating point data, right? Both this and this are floating point data. And we are trying to store it into an integer variable. So it's expected that there should be a compilation error, but there won't be a compilation error. Now what will happen is it will actually compute the addition because the this assignment operation, okay, the assignment operation has a lower precedence than a addition operation. So I earlier I talked about operator precedence. So in that operator precedence, the addition operation and the assignment operation has a precedence like this. So the addition operation will occur first and then the assignment operation will occur. So by the time the assignment operation occurs, the addition has already taken place. And as you can see, the value will be what? It is roughly, it will increase by 1.4, right? So it will be, can someone calculate this exactly and tell me what exactly is the value? Okay, okay, right. So the value here will be 10.5304. Okay, and yeah, it's written here as well. So what exactly will be stored in x? Now this is a floating point value which we are trying to put into the variable x. So what will happen in that case? Okay, can someone try this out? Try to save this and like print it. Print the value of x as an integer person using percentage %d and check what the answer will be here. Sorry, can you mute please? Yeah. Yes, the class is recorded. You will get the recordings uh, in the course page itself. Hmm. It does not come to 10.3. It comes to 10.53. The hmm hmm Yeah, right. So that is why you get only 10, right? So here answer is x equals 10. That is what will be the value that you will be storing. So even though you have done an addition of floating point data and you're trying to store it in an integer variable, what it will do is it will do the addition, the addition, because the addition operator has more precedence. So it will do the addition. Once addition is done, you have some value. Now you're trying to assign this floating point value to an integer variable. So in that case, you will have like certain parts will be dropped based on what your value is. So here it is 10.53. So it does not, there is no rounding up or down that happens. No rounding up that happens. So you just have 10 here. Okay, that's x equals 10. Mhm. Yeah. Yes. Yes. You can put to check the value. You can put a percentage d and print it. Yeah. So if you have, okay, so I'm not very sure about that, but in scanf it is a bit more strict about the. So if you have specified that you are taking an integer and instead the user puts a floating point, probably it is going to throw some kind of a problem. But I'm not very sure about that. Like you can probably try that out and check, because as far as I know, it's a bit more strict compared to a printf statement. Yes, these lectures are recorded. Yeah. C also has dynamic initialization, but can you tell me what dynamic initialization is? Mm, what do you mean by that? That does not mean what. Okay, that is not dynamic initialization. Like you're talking about storage specifiers now, right? So there is a concept of storage specifiers, but it's there in C++. I'm not sure if it's there in C. There is a keyword called auto that you can use for saving, but it's beyond the scope of this class, so I'll not be covering that. Yes. Yes, exactly. But and usually it's about dynamic memory allocation, which will be a part of this course towards the end of, I mean, I think that's week 12, where we will see this malloc and calloc functions, which is used in C for basically storing, like allocating data at runtime. Okay, but it's still, we are way off from there. I mean, it's a long way there. So please limit your questions to what we are covering so far in the class. All right, now let's look at the next question. So if an integer requires 2 bytes of storage, that is, it's a 32-bit system. So one integer occupies 2 bytes. What would be the minimum value of a signed integer in C? Okay, D. Previous, uh, yeah, someone asked me to explain the previous question. Yeah. So basically, what happens here is you are adding up two floating point variables, floating point data. So the addition operation has more precedence than the assignment operation. So it first there is an addition that occurs. After adding, you get the value of 10.5304, and then it tries to save this value in this integer variable x. Now this is a floating point value, and you're trying to save it in an integer variable, so it will drop the digits after the decimal. And here, because the digits after the decimal is just 5, it's not greater than 5, you will have just 10 being stored in the variable x. Yeah. All right. So here the answer is option D. And why is that? So I told you that, so say 2 bytes means it's 16 bits, right? Now 16 bits, it's a signed integer. That means 1 bit for the sign. Okay, that means we have 15 bits now. And in 15 bits, how many different, like what is the least number that you could save in 15 bits? Like lowest number, 2 to the power 15, right? Negative of 2 to the power 15, because we are talking about the minimum value. That means you will definitely have something which is like one bit for the sign, positive or negative, that will be stored on the leftmost bit, and you will have 15 more bits to save the data. Yes, but the logic, the, yes, that is a formula, but the formula came from here. Like you need to conceptually understand this. Yes, the formula is definitely there, but conceptually this is what happens. If there is 15 bits for you to store the data, then you can have, let's say you put all. Okay, so you have 16 bits. The leftmost bit is for the sign. So let me just, okay. So one, so leftmost bit has 1. Okay. Now I put all this remaining 15 bits. So there are 15 bits here. I put 1 in each of them. Okay, I put 1 in each of them till the end. Now now if you calculate this number, it will be basically what you will have 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. And you will have a number which is basically 2 to the power 15, because that is the minimum, and minus, because we are asking about the minimum value. So this has to be a negative for sure. And the rest 15 numbers, we just set it to the maximum that it can. So 2 to the power 15 is what you will reach at the end if you calculate this. Okay, so the minimum value that you could store is minus 2 to the power 15. But yes, of course, like you said, we can calculate it as 2 to the power n minus 1 for a signed integer, right? 2 to the power, no, in that case, sorry, for unsigned integer, it can have a higher storage, like you are talking about the maximum value now. So it will be 2 to the power 16 minus 1, because all the bits are available for storing values. Yes, it will be 2 to the power 16 minus 1 for unsigned. Okay, so that's some fun with numbers. All right, now let's see some more questions. So I'll tackle this question first, it being the, yeah, just two questions. I think they are fairly straightforward. So you are saying that, okay. So here, basically, when I say that an integer needs 2 bytes of storage, that means you have 16 bits of storage, and it's a signed integer, so you have 1 bit for the sign. The leftmost bit will be reserved for the sign. And here it is, we are talking about a minimum value. So the in that leftmost bit, you will have a value of 1 for negative values, and 15 bits will be available to you for storing the absolute value of the number. Okay. Now, what would be the maximum value that you can put into 15 bits of space? Think about zeros and ones. Okay, ones are always higher, right? So in the previous lecture, in the previous tutorial session, we talked about how to convert binary to decimal and vice versa. So let's say you write the 16 spaces. Just put 16 spaces on your yeah, like just put 16 blank spaces. Put one on the leftmost part, that is for the sign. Now you have 15 spaces. Now in each of the spaces, if you put one, and then you convert this entire number to decimal. It is a binary number. Convert it to decimal. You will reach minus 2 to the power 15. That is the value that you will reach at. That is the minimum number that a signed integer in C can have if an integer takes 2 bytes of storage. On both cases, it's the sign is always on the leftmost. The no, the sign is always the leftmost bit. So it will be stored in this bit, no matter what. So 1 will be for negative, 0 will be for positive, but it will always be stored for signed integers. It will always be stored on the leftmost bit. Yeah. Okay, so let's look at this question. So if we have two integers, a which is 7 and b which is 10, and then we do some assignment operations. So what will be the value of b after the execution of this following code? So I think it's fairly straightforward. Try to answer this. Right. So right, all of you are correct. So a will be when you are saying a equals b, so the value of b will be stored in a. That means a will become 10. Now the next statement I write b equals a. That means the variable b, whatever value is stored in a, will go to b. So b will be 10. So the value of b after execution of the code will be 10. So all of you are correct. So let's look at the next question. So which of this is an invalid identifier? So when I say identifier, consider it as the same as variable. Yeah. So else is a keyword. So you cannot use it as a identifier or a variable name or whatever. So it has a very special meaning. Yes. Extern is also a keyword, but as you can see here, I have not written only extern, rather I have written extern underscore ad. So it's as a whole, it is not a keyword anymore. Okay, so if I had written only extern, then that there would have been a problem. It would have been a keyword and it would have been invalid. But because I added this underscore and ad, it's not a keyword anymore. Yes, I think it should be fine because C is case sensitive. So unless the keyword has been defined in the same manner, just changing the case of the letter should be fine in avoiding. But it's not a good programming practice to use those kind of identifiers. Ideally, yeah, it's not good programming practice, so it's not suggested to do that. But yes, I think there should be no problem. Yeah. Yes, go ahead, please. Mhm. No, the compilation occurs. Compilation has already occurred, but the execution happens line by line. So in this line, in the first line, I have two variables that are initialized, a as 7 and b as 10. Okay. In the next line, then I go to the next line. I say that a equals b, so a will have whatever value b has. So a will become 10. So a has already become 10 now. Now I go to the next line and I say b equals a. That means b will take whatever value a has, but a has already become 10 in the previous line. So that will take. So this is not a compilation problem. This is an execution thing. So the execution will still occur line by line. Yeah. Okay, now let us see if you can answer this question. So we have an integer variable, and we are just adding up a value, and we are trying to print. Okay, but what if I say, what if yeah, correct. Why is it option C? Whoever said that, can you explain? Someone said option C. All right. So okay, now here something to note is that this starts with a zero. That is a very peculiar way of writing a number, right? Like integer. Why would you start it with a zero? Because if you it does not have any meaning to start it with a zero. Okay, but in C it has a meaning. So if you start it with a zero, the number that is following is going to be treated as a octadecimal. So this is how you treat, like, you can write octadecimal numbers. Now, if similarly binary numbers, you will start with a 0b, 0b, then 1 0 1 0 0 0, whatever. So this will be treated as a binary. Okay. Similarly, OX stands for hexadecimal. So you can have A3, F7, whatever, whatever. So this is hexadecimal. So similarly, here it is octadecimal or octal. You could say it's a octal. So it's a octal numbering system. That means 110 is a octal number. Octal number has a base 8. So try to convert this to binary. Do you remember how to do that? You would have to start from here, 8 to the power 0, 8 to the power 1, 8 to the power 2, multiply it, add it. How much would that give you? Right. So that would be 72, right? So this number basically is 72. It's not 110. It is 72. So variable will store this variable var will store the value 72. Okay. Yeah. So here, if you start a number, like if you initialize a number starting with 0, like an integer, you start it with 0, then it will be considered as a octal number. Okay. Similarly, if you start it with 0b, it will be considered the part following it will be considered binary, and 0x, then the part following it will be considered hexadecimal. So now if you are writing in hexadecimal, to do this calculation plus 7, right, you have to first, like, for you to evaluate, the computer will convert it to binary and will do the operation, but for us, we can understand decimal, right? So we'll convert it to decimal first. So 110, so 0110 is what is written. So 0 means it's octal. Now 110 is the octal number. It has a base of 8. Now we have to convert it to a base of 10. So we have to multiply it as such. So 0 will be multiplied with 8 to the power 0. 1 will be multiplied with 8 to the power 1. And 1 will be multiplied with 8 to the power 2. And then we add them up. So once we add them up, we multiply and we add them up, you will have 72. And that is of base 10. That is a decimal number. Now when you add 72 plus 7, that will give you a value of 79, and that is what is going to be printed as a decimal percentage d, so that it will print 79 for you here. Is that no, no, it's not add. So, okay. So this, if I write it properly, so this will be 8 to the power 0 plus 1 into 8 to the power 1 plus 1 into 8 to the power 2. So that gives you 72. Yes, if you are initializing it in the way that has been done here and it starts with a 0, that means the compiler understands that you are trying to give a octal input to it. Okay, not a binary or hexadecimal or decimal, but a octal. Similarly, for binary, it will be 0b. For hexadecimal, it will be 0x. Yes, ideally, I mean, it's not you who will be considering, it's the compiler which will be considering that it's a octal, because that is the way that that is the syntax for defining, for initializing hexadecimal or octal or binary numbers directly. Yeah. Yes, so the notation here, you start with just a 0 and then the number. So for binary, what you do is you write 0b, 0, then small b, and then the binary number. Okay. Similarly, for hexadecimal, you write 0, then small x, then whatever hexadecimal number. Yeah. Okay, then we'll go to the next question. All right. So what do you think should be the solution of this? So you have two integers, you are entering two integers through scanf function. Okay. Then you are adding them up and then you are printing the sum. So what should be the output here? Like, yeah, why? And we have ampersand here. See? One by one. Someone said address. I like it. Okay. So the problem is with this. Yes. It does, but the format specifier has to be according to the value. Okay. So here, when I say sum is a variable which is an integer variable. So it's a variable which stores integers, right? Now, when I say ampersand of sum, that means it is referring to the address, memory address of this variable, right? Now, the memory address of this variable and the value of the variable are not the same. The value is an integer. The value that sum stores is an integer, but the memory address of the variable will probably be in hexadecimal. For most of the systems that you will be using, probably the memory address will be hexadecimal. So this will definitely lead to some kind of error or warning, because you cannot print a uh, like an address using percentage d. Percentage d does not support address, it supports integer values, right? So it needs to find an integer value to print, not an address. An address is a like a complex, it's a combination of things. So to do yes. Ye- You have to use percentage P. Yes, percentage P will give you address. Like that is the format specifier for address. Yeah. So that is what is the issue with this particular code. All right. So yes, why not? I mean, you can print whatever you want. Address is also like it's possible to print addresses. Why not? No, no. So why scanf has this scanf has the syntax where you need to whatever you enter here, whatever the user enters directly gets stored in the address. Like it's the syntax of scanf that it will store the value what has been entered by the user to the address uh, of the of these variables. Okay, but printf is more flexible. It can print whatever value that you give to it. If you have mentioned the correct format specifier. So here the problem was that we were trying to print an address and we gave integer where the format specifier for an integer, which is wrong. So if you want to print an address, you have to give a format specifier of a address, which is a percentage p. Okay, so that was the problem here. So but printf is quite flexible. It prints whatever value you give it to it. All right, now someone else was asking something. Yeah, so scanf has a rigid syntax. Sorry, I'm not able to hear your voice. Can you just put it in the chat, the your question? So what I was saying is scanf is quite rigid in its syntax and makes it mandatory to put the address of your variable when you're trying to take data from the user. So that is why you need to mention ampersand a ampersand b. Okay, so that whatever data is input, whatever numbers are inputted by the user will directly get stored in those memory locations. But printf is more flexible with its with the way it handles its whatever you're trying to print. So you can print values, you can print addresses, you can yeah, you can print more or less anything you want using a printf statement. So it is much more flexible in that. So here I wanted to print an address. That is why I used ampersand then sum, because I wanted to print the address of the variable sum. But for that I would have to use the format specifier percentage p. Percentage d will not give me the address of, like it will not be able to hold the address of any variable because it only holds integer value. Okay, so I needed to use percentage p if I wanted to print the address. Like I said, percentage d is a format specifier for integer values. Percentage p is a format specifier for addresses, memory address. It can be hexadecimal, but like it's usually like a combination of a lot of things. Like it's not, yeah. But here we are talking about decimals, right? It is percentage d. So when I say integers, I mean particularly decimal integers. That is why the d comes from, right? Percentage d. That means decimal. So there are certain formats I think you can write for hexadecimal as well. So that would also work because memory addresses are mostly in hexadecimal. If you use the format specifier for hexadecimal, then you can also print. You don't need percentage %p in that case. Okay, you can still print the memory address if you use the format specifier for hexadecimal. Yeah. Uh, Sorry, what is required? Yes, yes. So sum, just if I write sum, that means it. I am referring to the value that is stored in this variable sum. When I am saying ampersand sum, that is referring to the memory location of sum, the variable sum where it is stored in memory, that memory location, that memory address. Yeah. All right. So this will be the last question from me, from my side. So we have a C code here. Yes. Uh, okay. Okay. So basically, here, so every, as you know, every variable, say variable A, here you have your RAM, you have your variable. Variable has two properties. So one is its memory location, so where it is located in memory, so the address and the value. Okay, now this, if I talk about variable A, it would have a particular memory location somewhere, a memory address, and it would have a value. Now the value is being taken from the user in this case. Okay, and I'm adding it both A and B, and I'm adding up the values of A and B, and I'm storing the value in a variable called sum. Now the sum is also present somewhere in the RAM. You have a variable called sum, that is a memory space that has been allotted to this variable, which is sum. And now then, what I tried is I tried to print the value of, not the value, but the memory location of this variable sum. That is why I used this ampersand. So when you write ampersand then variable, it will give you the memory location or the memory address of the variable. Okay, instead of the value. Just writing var will give you the value that is stored in the variable. Okay, so now I was trying to print the memory address of this variable, but I was using the wrong format specifier, which is the decimal format specifier for this. So instead of that, because this memory address is a hexadecimal, I would have to use either %p or the format specifier for hexadecimal in order to be able to successfully print the memory address of this variable. Okay. Now, is it a bit more clearer what exactly was the issue with this code? Yeah. Okay. So let's see this question. So we have a float, a float variable which is a. We are storing a value of 7.0 to the variable, and then we are printing an output with some, like some calculations, and then we are printing. So this is, should be fairly straight. Okay. So 13 by 5. How much is 13 by 5? 2.6, right? Mhm. So every one of you has answered option A. Does anyone? Okay, okay. So what if I say the answer is not option A? What would you think would be the next logical answer? Okay, so those who are saying option C, can any one of you explain why option C? Mm-hmm. Mm-hmm. Okay, so if you do this computation in your uh, whatever compiler, you will get an answer of 24.00. Why that is because of this braces, mostly because of the braces actually. So what happens here, this 13 by 5, you're doing a division of 13 by 5, and notice that both of these are integers. Like the way that they have been written, they are integers, right? I have not written any 13.0 or 5.0. So both of these are integers. So it's 13 and 5, both of them are integers. Now, when I do 13.5, the answer should be 2.6, right? But because I have done a computation between two integers, the answer will be an integer, and because of this parenthesis as well, because that is the computation that is taking priority, which is inside the parenthesis, it's taking priority. So it is a computation, it's a operation, arithmetic operation between two integers, so it will give you an integer. So it will not give you 2.6, rather it will give you 2. Yeah, I'll explain it again. So basically here 13 and 5 both we have written as integers. Okay. So if you had written 13.0 by 5, then your answer overall would have been 28.2, right? Because this is no more an integer. So this would have become a float. This would have been an integer. So this would have given you a float. Now you are dividing an integer by an integer, so it will give you a result of an integer. That is like a peculiarity with C, that it follows this kind of thing, where if you divide two integers, you will get an integer as an output. It will just ignore the place after the decimal. So it will give you 2 here. And then out of this parenthesis, the 2 comes out of this parenthesis, you multiply it with A. A is now 7.0, so the entire thing becomes a float. So 2 into 7.0 will give you 14.0. Okay. Now 14.0 plus 10 will give you 24.0. And then it will see it has percentage point 2f. So it will print up till 2 decimal places. That will be 24.00. Sorry. Yeah, yeah, go ahead. Well, it does not get round off. That's what I can tell you. It just drops the entire decimal part. So this actually is something that someone asked earlier, I think, that what would happen if there is a decimal, like there is a floating point, and I try to force it into being printed as an integer or something like that. So maybe this is what happens. Like you have the decimal places just ignored. There is no rounding up, and that is what happens. But I would say to try it out yourself. But in this particular case, if you are doing a integer arithmetic operations with integer, there will be no rounding up. It will just drop the value. It will take whatever integer part is there. All things after the decimal will be dropped. So only 2 will be taken from here, not 3. Yes. Uh, yes, I think you should get that. Let me think. 13 by 5. Yes, I think you should get. Hmm, that is good question. Maybe try this and find out, because the operation, like according to the precedence that we are talking about earlier, and the associativity, the operation will start from the left to the right. So 13 by 5 will be evaluated first anyway. So 13 by 5, yeah, 2.6, but whether that zero point 0.6 will still stay or not is a doubt, right? Like whether it will be 2 or 2.6. Okay, let me do that quick operation and let me calculate that for you. So let me, yeah, you can also try this on your own computer just to check what happens. Yes, you will get the PPT as well. Both the PPT and the lecture will be uploaded to the website, to the course page. Are you sure? Because on the compiler that I am using, it gives me still 24, even if I remove the braces. Like if I just remove the braces, I don't write 13.0 or 5.0, it still gives me an answer of 24, which I think is understandable in a way. So hear me out. So if I write 13 by 5 into A, and as you know, this division and multiplication operators have the same precedence. So we will go into associativity rules. Associate, Associativity tells us to go from left to right. Uh, so can you please mute? 13 by 5 into A. So you have an operator associativity rule here, which tells you that it goes from left to right. Um, so now 13 by 5, when I evaluate 13 by 5, I get 2.6, but because both are integers, I get 2. Okay. Then I multiplied it with 7.0 and I get 14.0. So it still makes sense that the answer should be for 24.00 overall. Okay. So even if I remove the braces. So that makes sense to me. Yeah. Yeah. All right. I had a few more basic questions for you, but I think you'll be able to solve them on your own because we are more or less out of time for the course. I will put this PPT on the along with the solution of this last few questions as well. I will put the solution and the PPT on the website. So, are you able to find the previous lecture recording and the PPT? It's not available to you. Okay, okay, then it's available, right? So, you will get it as a PDF format. So, is anyone able to see the first tutorial class PDF or the recording? Has anyone? Okay, the PDF is not available to you. Okay, okay. But that link is not shared with you, the link to the PDF, or are you not able to open the PDF? Okay. Okay, then I'll do one thing. I will give you a link uh, for the folder where I put all the PDFs so that you can directly access it. Okay. Probably they will put it on the SWAYAM portal soon, but I will give you the link right now. Okay. Sorry, your voice is not very clear. Can you just try to repeat it or write it in the chat? Okay. Okay. Yeah, I mean, these are all questions that the questions that I'm discussing are not part of the assignment. So basically, these are extra questions. Okay, so for your practice, but also you can refer, uh, yeah, but on the internet you can find a lot more questions for practicing all this. All right then. So thank you for joining this session. So we'll meet next Tuesday for discussing some questions about week 3 lectures. Okay. Thank you. I'll be closing the session now.